Mike Miller comes into the Hardy lab and finds the lab littered with tennis balls. Why? Because students were throwing tennis balls at pigeons. Yes, pigeons. See, the rafters in the Hardy lab are not enclosed, and so pigeons who manage to make it in there think it's a nice spot to set up a nest, and so students throw tennis balls at any pigeons they see to discourage them. Although it is a nice gesture, it leaves Mike stuck with cleaning up the tennis balls. Therefore, Mike needs a device to collect the tennis balls in a collection bin for easy cleanup. Currently, Mike walks around the room bending over and picking up each ball individually, then walking to the collection bin and dropping them in. Sometimes, when he's feeling lucky, Mike throws the tennis ball as if he was trying to make a free throw, and then must go and pick up any tennis balls that miss the bin. To try and help Mike out, we first started by researching devices that can shoot or throw tennis balls, and then made a list of devices that were powered using only stored mechanical or gravitational energy. We then identified the key working components of each device and used the decision matrix to decide on which components we would include in our design based on their accuracy, reliability, adjustability, simplicity, and mobility. After we ranked each component, we then built a prototype which included the best components determined from the matrix. Our solution is similar in style to an artillery mortar, using 2 extension springs and an interior ball holder to propel the ball instead of using gunpowder. The springs are held in place using a string with a loop that runs out the back of the barrel and connects to a crossbow-styled trigger. Once initial testing began, we had a couple of key components break. One example is the trigger on our crossbow trigger assembly. We repaired this by printing the entire assembly out of PETG plastic using the 3D printers and by making the components bigger. Later, we had a key piece inside the barrel that transferred the motion of the springs to the ball. This was initially made out of PETG plastic, so our solution was to increase the fill percentage when the part was printed. Once we had repaired and strengthened these components, along with a few others that broke during the testing phases, we then tested our device's accuracy, simplicity, and durability by firing tennis balls into a collection bin for a continuous 3 minutes. 16 of the shots went in at a range of 1.5 and 6 meters away, which works out to be 1 basket every 11.25 seconds. We are happy with this result and think that our device would be adequate for the task at hand.
I'm sorry, Mama. Mama.